I think we can start. So thank you for being here. We're the MATLAB student ambassador here at Politecnico. So we're the point of contact between the Polyme students and MathWorks. We will organize some events during the year and some workshops about MATLAB and about Simulink. And now you should have, all of you should have 3 cards. If you don't have the 3 cards, please raise your hand. Marco will give them to you. Okay, perfect. If you're following this event from home, please get a set of cards, of playing cards, and get 3 cards from your set. So the agenda for today is divided into 3 parts. First, we'll start with an introduction to deep learning and transfer learning, some basic concepts in MATLAB. Then we'll move on to a coding session, and we'll train a neural network to recognize the cards that you have. We'll deploy this neural network into a poker application and have some additional resources at the end to get you started, and the contest with Before starting, please check that you're ready. Yeah?
Please close the level.
Okay, thank you. So before starting, please check that you are ready. So have your PC with MATLAB opened, and check that you installed the add-ons written in the form. So deep learning toolbox model for Google Net Network, and the MATLAB support package for USB webcams. If you haven't installed them, you can find them in the add-ons explorer here. So open MATLAB in the Home tab, and you can search them here. To check that you have installed them, you can type into the command line net equals to GoogleNet here, and cam equals to webcam1, and preview cam. If no errors show up, you're good. If you have some errors, you can raise your hand, and Marco will come and help you. 10 seconds. If you're following from home, just write something in the chat or answer in the chat. Okay, so move forward.
I did write in the blackboard.
Marco this line, so you can.
If you have issues, try this line and see about each one. Maybe you have some 2 or more.
Okay, so let's start. So what is deep learning? Well, deep learning is a subset of machine learning. Okay? Deep learning is a subset of machine learning. So the question becomes, what is machine learning? So machine learning is a branch of artificial intelligence and is the study of a set of algorithms that you use when you have a large number of data and you want to make predictions or recognize patterns. The 3 main problems that you can solve with machine learning are regression, clustering, and classification. Today we will focus just on image classification and the difference between traditional machine learning and deep learning is that, for example, say that you want to recognize a number. So you want to give your algorithm some numbers, and you want your model to tell if it's a 3 or 4 or a 6. In traditional machine learning, you should extract manually some features from this number. Say, for example, the color of the number or the curvature of the number, the size of the shape, calculate them, and use these features as an input for your model. in deep learning, the input of your model are not the features, but the image themselves. So your model automatically learns and extracts the features during the training process. So to summarize, deep learning is a subset of machine learning with automatic feature extraction. It learns features and tasks directly from data. You don't have to extract them. It is implemented using a neural network architecture, which we'll look at in a moment. And the term deep in deep learning refers to how many layers there are in this network. The accuracy can surpass traditional machine learning algorithms, but deep learning algorithms require far more data. Okay, so deep learning models at their core are just neural networks. And so what are neural networks? Neural networks, by definition, are a set of neurons that can perform computations on input data to predict what the input object is. They're fairly complicated, so we don't want to dive into the technical details. What I want you to know is that you can divide a neural network into many layers, and so have an input layer with many neurons that can take in some data. This data gets passed into the other layers in the middle that we'll call hidden layers, and they perform computations on this data, and they can extract features from this data. And finally, you have an output layer, which will give you the classification output. But how can a neural network perform computations on things like images or audio files? Because they're numbers. So images are just represented by numeric metrics. A colored image is m by m by 3 metrics. 3 are the primary colors, RGB. And signals and texts are just numeric vectors. So we will have this kind of neural network here with an input that is an image. And this type of network that we will use is called convolutional neural network. Convolutional neural networks are networks that work very well when the input data is inherently bidimensional, as in the case of an image. Then you have the hidden layers in the middle, the image and the features, and the output layers here. These last layers, we will look at them during the coding session, so don't worry about them now. What I want to stress right now is that this is the architecture of your network. So how many layers there are, the type of layers, how they are connected. And the architecture, once you build your network, is fixed. But all these layers, most of these layers, come with some parameters called weights. And these weights are not fixed. They change in a process called training. So your neural network will be trained on some dataset. It is an iterative process. And as the network is trained, these weights will change to try and accomplish your final result. So say, for example, you want to recognize. Just a moment. Say, for example, you want to build a model to recognize birds and planes. You just get 1,000 pictures of birds and planes, use them to train your model, and as your model is trained, the weights slowly change to try to identify what the features of the plane and of the birds are. This means that you could have two networks with the exact same architecture, but that behave very differently as they were trained on the dataset. So this one up here will have the correct result. Will recognize the penguin if it is trained on the right data, and this down here will recognize it as a tree, even if it has the same architecture as the one above. Okay, so now we'll take a brief look at what we will do today. So here's the deep learning workflow. The deep learning workflow consists in 3 parts. First, we have to prepare our data. To prepare our data, we have to label our images and pre-process them. We'll look at it in just a minute. Then we have to build and train your model. And finally, usually you deploy your model or your neural network where it's needed. So maybe some other application or some hardware. Let's start with preparing your data. Some technical problems. Okay. First thing you want to do is to correctly label your data. So you want your network to recognize dog, lions, and cats. You prepare a lot of pictures with dog, lions, and cats, and label them. This is because this is called supervised machine learning. So your neural network has to learn from images that are already correctly classified. Then you want to resize your images. This will depend on the neural network that you use. The network that we will use is called GoogleNet, and only takes images of size 224 by 224 as input. So all images have to be resized. Another important step is to modify these images for a robust network. This is very important because you want your neural network to recognize pictures like a dog, even if it's upside down or slightly tilted, or not in an optimal condition of brightness. So some of the images have to be modified manually to account for these changes. And finally, you have to split your set of images into a training set and into a validation set. This is very important because the training set, as the name implies, will be used effectively for training your neural network. But during the training, sometimes some images of the validation set will be used to validate your network. So to see if it's correctly predicting the pictures of the validation set that it has never seen, or if it's not going to the right direction. The most common way of splitting this set is 70% and 30%. Okay, so now we'll talk about how to build a neural network and what we will do today, but what we will do.
Once you have your dataset, you have to create your neural network. You have many options in order to do this. You can train your model from scratch, but this requires a lot of time and also a lot of knowledge, because you have to choose layers, arrange them in the correct order, and choose the biases in order to get the right network and to get a good classification of your dataset. Another option is to perform transfer learning, which means use a pretrained network, such as in our case GoogleNet, and retrain it with a new dataset of images that you need to use, and get the network be able to classify them. So for the purpose of this workshop, we will use transfer learning. Just a brief overview about pre-trained neural networks. We will use GoogleNet, which has been trained over millions of data points and is able to classify 1,000 objects, such as a keyboard, mouse, and many animals, as we will see. It has been designed and created by research of Google, and it was developed nearly 10 years ago. So here are some examples of pre-trained networks. They are divided in groups. We will just point out AlexNet and GoogleNet, which are very easy to get started with because they are fast and they have a good accuracy. But we also point out SqueezeNet in order if you want to use it in your, for example, hardware application or to deploy it on a Raspberry. It's lightweight and so it's faster in this application. As you can see, they have a different performance in terms of time and accuracy. AlexNet is very fast, but also the least accurate, while other networks have better accuracy, but require more time. So what is transfer learning? Transfer learning is the process which we will follow today, and means take a pretrained network, and this is easy, it's just a line of code in MATLAB, and replace the final layers. In our case, they will be the fully connected layer, a softmax layer, and a classification layer. We will do this because GoogleNet is able to recognize 1,000 objects, while we just need to recognize 52 cards. And so we will replace them and change the parameter of the number of class to 52, or in the case of our model, to 3. So once we do this, we will submit a new set of images in order to train the network. In order to classify tens of classes, we will need just thousands of images, not millions as for the internet. And at the end, we will test our model. Of course, this is not a linear process because we will have to repeat these last two steps in order to gain a better accuracy and to have a good model for the dataset, as we will see in a moment. Just the last part, if you want to deploy your model, you have different options. You can deploy it on GPU or CPU, and for example, on Raspberry machines. But you can also upload it on a web application or standalone. So let's dive into the code. What is the goal of today? The goal is to create a network which recognizes MATLAB cards, and we will do this using GoogleNet. And once we have done this, we will leave you play with a poker application, which you see here, and it will recognize card and let you play poker. Okay, so here is the link to download the initial code. We will leave you a moment to do this, and we will write also on the blackboard. If you are ready. Okay, if you are ready, we can go on. It's okay. 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 So before starting with the deep learning part, we give you some initial example, some function of image processing. So we start with reading an image. So we define a variable named img, and we use the command imRead, which take as input the name of the image. As you can see in LiveScript, we have this help, which is very useful because it's very well implemented, and as we will see later, it's possible to autocomplete. So now we are going to read the cat image, as you can see here in the left. So we type cat.jpg, and we run this section. In order to run a section, we have to press run section here in the top. Or if you want to use a shortcut, use command enter or control enter. So if we run this section, we can see on the right the output. This is a 480 times 758 times 3 matrix, which means that an image is a 3-layer matrix made of integers, and this is the intensity of the red, green, and blue color in the image. Of course, remember to add a semicolon at the end in order to don't see this every time you read an image. So to show the image, we have the command imShow, and it's imShow of the variable, so of image. We run again this section, and as we can see, we have the image of our cat. Yes, for the text. More? Okay. Okay. So, once we have import our image, we have to resize it in order to feed this to the model. So we have the command im resize, and we will rewrite our image. So we type img equal to im rewrite. Sorry, resize, of course. I noticed this because the code did not give me a hint, and so it was not the right command. We have im resize, and we have as parameter the image and the scale. So we type image, and the scale is 224 times 224. Semicolon at the end to suppress the output. And we can show also in this case the image. For run the code, command enter. As we can see, it has been resized into 224, 224. Okay. Now that we have seen how to do this for one image, let's see how to do this for multiple images. And in order to do this, we use image data store. So we create a new variable, which take image data store. And we also, in this case, have as parameter the location. And so we will use test.ds as a folder in this case. So we type test.ds, autocomplete. To autocomplete, you can use a tab in your keyboard. Just test start. And we will also add some parameters, which are include subfolders. So we can type it, or it will show up, and use tab to autocomplete. And we set this to true in order to read the subfolders. And for the purpose of deep learning, we will use also label source. And the label source it will be, we can see here the int, it's not like this. You can see we have different options, which are folder names or none. We will choose folder names. If we run this, we will see the object image data store with these properties, which files stand for a list of the file in the data store, and folder are the folder which has been read. Okay, what can we do with a data store? We can read images. The interesting thing about data store is that they does not store all the image in the variable, but they are just an instrument, a function, to read the function one by one. And so they are fast and smart in the memory usage. So to read an image from a data store, we create a variable, image 2 in this case, and we use read image from a data store, imgs, and we have to provide an index. In this case, we will use 2 in order to read the second one. Also, in this case, we will show the image. Show image 2. Okay. let's try to classify this image with GoogleNet. So we import GoogleNet, and this is very easy because we just have to type net equal GoogleNet. This may take some time. So we resize our image as before, image2 equal to imresize image2 and the dimensions. Remember to add a semicolon at the end. And finally, we classify it with a classify function. So we create a variable named Fred equal to classify. Classify take as input a net, which we name it net, and the image, so image2. If we run this, we get the prediction to be tiger cat. As we can see, this is very accurate and, of course, right for this image. As we said, Google were trained to recognize animals and many other objects, but is very, very accurate in animals. Here you have an example of code, which we will not write, but just run. You can see that classify can give us output two parameters, which is a prediction and a score. Score is a vector of the confidence on the prediction, and so will tell us which level of confidence the net gave to our result. And so if this is just an indexing, a Boolean indexing, we take the score greater than 0.01, and this will be a vector of 1 and 0, and we use score to plot just the score higher than 0.01, and the last two lines are in order to add the label to the plot. We run this, and we see that the model predicts tiger cat, but it predicts tiger cat, while the other option were tabby, which is Soriano, another type of cat, or Egyptian cat or lynx, which all the possible options were maybe good for this image, but he chose the right one. If we try the same process with another image, we read the first image in the data store, which, as you can see, is the ace of spades. And we try to classify it. We'll obtain a prediction of envelope, which is a busto da lettere, which, of course, is not the correct one for the card. So we have to perform transfer learning in order to get the net to be able to recognize this card. How do we do this? We have at first to create our data set. So we run this section. I show you what this section does. Here we create the arrays of the suite and the rank in a full extension or in code. And we run this while loop, which will take shots of our cards from the webcam. We have a cam equal webcam 1, which means we take the first webcam of our computer and we preview it in order to see what's happening. I'm not gonna spend time on this, but here we create the directory and take the pictures. If you have installed the Process Image Toolbox or you want to try, you can uncomment this section, which will rotate random image once every 2, or adjust the brightness in order to get a robust network. But if this does not work, comment this section and we will do this later in another way. So let's run this section with a run section. Okay, as you see, the webcam started. I suggest you to use a split view with MATLAB on the left and the webcam on the right, or as you prefer. I don't know if you can read here. In the command windows is a show card name in a short form. So we now take one card. Okay, I take a moment in order to let everybody arrive here. Well, I tell you how to do this, so the one who are ready can start. For the other, don't worry, we will help you now. Type the card name in short form. For example, this is a queen of clubs, so queen Q, clubs C. I type queen of clubs in capital letter, place it in front, and enter. It will start taking images, so move the card in front of the camera, rotate it, tilt, and do whatever you like in order to get different photos, different shots of the card. This may take some time, and if you have time, do this for 3 cards. If you type capital N, it will quit the operation. Do this for the 3 cards that you have. Remember to move the card in front of the camera, tilt and rotate, do whatever you like. If you are not able to do this, don't worry, because there's a checkpoint after this, which will import a brand new data set in order to proceed. Okay, I help you. If you need, raise your hand.
Okay, so let's go back. So now, if everything is done correctly, you have here your cards folder, and in this folder, 3 different subfolders with the name of the cards you just classified. And in each of these subfolders, you have 100 different pictures of your cards. So we have created and labeled our data. So now let's create a database so we can start working on it. So first of all, we need to import this card in our workspace. We will use, since there are tons of cards, an image data store. So EMDS equals to, and then we'll call image data store. Then we have to give in the path of the folder, which is the cards folder. So cards. Then we want to include all the subfolders because the images are in subfolders here. So include subfolders, auto-completing with tab, and then true for the option. And finally, we want to use the label. We want to use the name of the subfolders as the label of the images. So we will use label source and folder names. Here is the entire line. Let's run this section. And now we have our image data store. If you're behind, now you can just uncomment this line. We provided a backup with some photos of cards. You can just uncomment and run this line to get up. Okay, so we have all our images in our data store. Let's split it into a validation set, into training set. We will use a function which is called split each label, already implemented in MATLAB. So EMDS train will be our training set, and EMDS validation, our validation set. We'll call split each label. We have to pass the image data store, which is called EMDS. Then you can see there is P. P is the proportion of images that will go into EMDS train. We want to split it 70% into EMDS train and 30% into EMDS validation. So we'll write 0.7. And finally, we'll use randomized. This just selects random images and not just the first 70% of the images. Let's run this section. Okay. Now we have to resize the images in our dataset to be fit for GoogleNet. So let's create two augmented datasets. So what are augmented datasets? Think of them as just image data stores with some additional function for reshaping, resizing, rotating, and tilting. To create them, we can use the function augmented image data store, already suggested. As you can see, we have to give in the output size. So 124, 224. And then the image data store. This is odds train, so we will use EMDS train. Okay. Then we do the same, but for the validation. We'll call it EMDS validation. We will call again the augmented image data store. The size is the same. And we will use EMDS validation as the source for this augmented image data store. So, okay, let's run this section. And now we have all our images in these data stores and correctly resized. Now, this section we already. Yeah, of course. No problem.
You can find this in the next section.
Okay. So the next section is already written. This is just for the robust network that we mentioned earlier. So we want our network to recognize upside down images, these kind of things. So we will call again augmented image data store, and this will apply a random reflection with probability 1/2 on the x-axis and the y-axis, and the random rotation between -20 and 20 degrees. So just run this section to get all the options applied. Okay, so now we move into the final part. This part will be done without a single line of code. We will use an app called Deep Network Designer. So here, up here, you can find the apps. And here, you can find the Deep Network Designer. So just click on it. It will take some time to open. So now our data is ready, and we need to perform transfer learning. This means that we have to load a pretrained network and then change the final layers of this pretrained network to retrain it. Okay, so now the Deep Network Designer is correctly opened. And we want to load into the Network Designer a pretrained network. So we will use the Google Net network. So here, just click Open. And the Deep Network Designer will load it into GoogleNet. Okay, so here you have the whole structure and architecture of GoogleNet. It's fairly complicated, but we don't need to look at all of this, just the final layers. So I'll just zoom in here and move on to the final layers. What we're interested in are the three final layers: the fully connected layer, the probe, the softmax layer, and the classification layer. So what these layers do is substantially get all the features from the previous layers and map the features onto the outputs. Okay. The softmax layer turns these features into a probability distribution over the different categories, and the output layer gives the final classification. As you see, in the fully connected layer, the output size is 1,000. This is because the GoogleNet network can recognize 1,000 different categories. In this case, we want to recognize just 3 different categories, the one that you've taken pictures of. So here, we need to cancel and delete this layer. And you can see that here, from the menu on the left, you can drag and drop another fully connected layer. So drag it and drop it here. And change the output size to 3, the categories that you want to classify. Then connect it into the softmax layer. And we want to do the same thing with the output layer. So delete the output layer. Here you can go down. Okay, and drag and drop the classification layer. Okay, here the classes and the output size are automatic, so we're ready to go. If you want, you can analyze the network and check if there are any mistakes. This may take some time, so we know it's right. I suggest you not to do it right now. Okay, we can also export our graph into our workspace. Here it's exported. Okay, and you can see I have it here in my workspace. So now let's train our modified network on our data. So let's switch here to the data tab and import our data. You can import the image data store, clicking here from import data, and you can see that MATLAB automatically recognizes your augmented image data source, so old train and EMDS validation. Click import, and if there are not the right augmented image data stores, you can just select them from the drop-down menu. Click import. All your data are imported into MATLAB. You can see here the preview of the pictures. Okay, so now let's switch to the training part. Before starting the training part, let's have a look at the training options. So the training options, you don't have to know all of these things. You can just leave them as default if you don't know them. Let's just have a look at the solver, which will be by the stochastic gradient descent method. The initial learning rate sets how aggressively the weights are changed in your model. We want to start with a slow initial learning rate, so we'll set it at 0.005. Then training is an iterative process. So with each iteration, some images are taken and used for training, and the number of images taken each iteration are the mini batch size number, and we'll change it to 64. Once the model has seen all the images in your dataset, that's called an epoch. So the max number of epochs will set the maximum number of times your model will see the whole dataset, and we'll set it to 6. Finally, the validation frequency sets how frequently your model will stop training and use validation images from validation dataset. And let's use 6 also for this parameter. Leave all the other things as they are, those. And now you can start training. Okay. Training is quite a long process. It will take some time, usually 4 or 5 minutes. The window will open up. And here you can see something training. There are 2 graphs, one here, up here, and one down here. These graphs are used to see how the accuracy is performing during the training process and how the loss function is performing. So just to give you some general rule, the general accuracy should rise during the epochs and the iterations, and the loss functions should decrease. Okay, so start your training process. As I said, it will take some time. So while the training process goes on, you can do the quiz and the contest. Here you can find the link to the quiz. So please use the link. If you want, you can do the quiz. And within 7 minutes, we'll get the result.
We leave you till 50 to complete the quiz. Meanwhile, I show you how to test the network. And so if you want to look at the blackboard, you will see. Okay, for you who have been able to complete the training, export your result here. And run the last section. important thing, if you don't see this, make the windows bigger in order to see this part. As you can see, if I show a card, it recognizes it. Queen of clubs, ace of diamond. And you can see the name of the card and the confidence of the prediction. Of course, thank you to everybody. We hope to see you in the future. And don't forget to follow us on Instagram and Facebook. We will leave you the name on the blackboard. And hope to see you soon.